Hello, this is question 16 on your sample paper from AQA. It's paper 1 and it's a mechanics question. So you have a particle of mass 400 grams is initially at rest at the point O and the particle starts to move in a straight line. So the velocity is this expression here in terms of time. So this is a variable acceleration question. And sometimes you get confused with these questions, but they are quite simple. So find an expression in terms of t for the force acting on the particle. So we know the force acting on a particle would be mass acceleration. We know velocity is in terms of time, so acceleration is very likely that is in terms of time, and that force then will be in terms of time. So this is what they are asking us. So remember that for these questions, we have the position vector. When we derivate this, the expression of the position vector, we have the velocity, because the velocity is the change in position vector or in displacement. And when we derivate again, we have the acceleration, because the acceleration is the rate of change on velocity. So we have an expression for the velocity. If we want an expression for the acceleration, we have to derivate that. We have to derivate this expression. So the acceleration in terms of time is going to be derivative of the velocity. So it's going to be 12t minus 36t squared. Yeah, that's the expression of the acceleration, which means the expression for the force is going to be the mass, which is this one and is constant. Remember, it has to be in kilograms, so 0.4 times the velocity expression, which is 12t minus 36t squared, and we can multiply this to get the proper expression, or we can leave it with the bracket, but I'm going to write both. Yeah, t squared newtons. So our force is in terms of the time. And the next part, so B, they say find the time when the particle next passes through O. It says at the beginning that the particle starts to move in a straight line and is initially at rest at the point O. Yeah, so we need to know when the particle passed again through O. So if we have a point O and the particle is moving from here somewhere else and back, we need to know what that happens. And in that case, R, the position vector, is 0 again. Position vector, if we see this thing here, position vector is this one. So if I have the expression for the velocity and I integrate, because I go in the other direction, I will have my position vector. So I can find an expression for the position vector integrating the velocity. The velocity was 60 squared minus 12t cubed. So I can integrate this. When I integrate, I have 2t cubed minus 3t to the power 4 plus the constant of integration. And I can find the constant of integration because I know the initially is at rest at point O. So when t is 0, initially when t is 0, position vector is 0. So if I substitute this here, when r is 0, t is 0, that means that c is 0 as well. So that helps us to find the constant. So c is 0, which means that my expression is 2t cubed minus 3t to the power of 4. And that position vector is 0 when the expression is 0, so minus 3t to the power 4 is 0. If I factorize, I have this thing here, minus 3t equals 0, which means that t is 0, so initially is at O, and we know that, or t is 2/3 of second, which is the next value when the particle is at O. Yeah, and that's all in this question, and this is 5 marks. Look, so it's quite a lot of marks for something that is quite simple. You integrate, find the constant of integration, and you find the time for displacement or position vector 0. Yeah, that's all with this question.